All right, guys, this is Mrs. Foy. Take a deep breath. This is a screencasting on factor labeling, but you can do this. So I would suggest that you maybe listen to the screencast a couple of times. The first time, maybe just watch me do the problems, and the second time, actually do them along with me, okay? So here we go. How many miles per hour is a car traveling if it covers 2 miles in 72 seconds? Okay, so first of all, I want to say that this term per, like if you say miles per hour, that actually means this. Miles per hour. Per means divide. That's a nice little thing to remember. So what I want is miles per hour. What I've got is 2 miles in 72 seconds. So I'm going to write down what I've got over here. I've got 2 miles in 72 seconds. And I'm trying to get 2 miles per hour. So obviously what I need to do is I need to convert my seconds to hours because my miles are already there. So converting time is easy because we already know those equivalences, right? There are 60 seconds in 1 minute, and there are 60 minutes in 1 hour. So notice that my units are going to cancel, right? My seconds cancel diagonally, one on the top, one on the bottom. My minutes cancel diagonally, one on the top, on the bottom. And I have hours left on the bottom, which is good because I want hours on the bottom, and I didn't have to convert with miles. So now what you're going to do is you're going to take your calculator, all right, your little handy dandy calculator. And what is happening with the math here, guys, is what is left on the top is 2 times 60 times 60. And on the bottom, there's a 72 times a 1 times a 1. And the unit that I have left on the top is miles, and the unit I have left on the bottom is hours. So it's 2 different ways you can do this. You could multiply 2 times 60 on the top divided by 72 times 1 times 1. Or you can do it a faster way on your calculator. So you could actually type in 2 times 60 divided by 72. And if you do that, then you are going to get, what are you going to get? You are going to get 100 miles per hour, okay? So the only problem is that, look, I only have 1 sig fig in my problem. So I have to put this in scientific notation. 1 times 10 to the 2 miles per hour. And then I'm going to circle my final answer. Okay? Let's try another one. All right, so this one says, how many quarts would fill a room if it is 2 meters by 2 meters, 2.5 meters times 2 meters times 2 meters? So the first thing I need to do is I need to know that volume is equal to length times width times height. So I'm going to take 2.5 meters times 2 meters times 2 meters, and that's going to give me 10 meters cubed. Okay, so that's going to be important. But I need it in quarts. So I'm going to need to write down that I want quarts as my final unit. I'm going to start way over here on the left, and I'm going to write down my 10 meters cubed. And I am going to need to use the conversion of 946 milliliters in a quart. I'm going to need to use that as a conversion. I'm going to need to use that there is 1 cubic centimeter in a milliliter, and I'm going to have to convert centimeters into meters in order to get this problem. So this is going to be a big factor labeling problem. Here I go. So the first thing I'm going to do is I'm going to say, all right, there is 100 centimeters in a meter, but I need cubic meters. So I need to do this 3 times. Okay? Now I can cancel out meters times meters times meters is cubic meters. And now I'm in centimeters times centimeters times centimeters, which is cubic centimeters. So now I can use this one. I'm going to put it on the bottom though, because I want to be able to cancel out my cubic centimeters. So centimeters times centimeters times centimeters is a cubic centimeter. Now I'm at milliliters, and now I can use this one, 946 milliliters in 1 quart. Milliliters cancels with milliliters, and I'm in quarts, which is what I want. So now what I'm going to do is I'm going to multiply all of these things across the top. So 10 times 100 times 100 times 100 divided by 946. But I'm going to use just a little shortcut here. I'm going to go ahead and know that this is all 10 to the 2. 10 to the 2 plus 10 to the 2 plus 10 to the 2. So I'm going to actually get 10 times 10 to the 6th divided by 946. And the only unit I have left is quarts. So if you do that, you actually get 0.0105 times 10 to the 6 quarts. And I have to put that in scientific notation. So I'm going to say 1, 2, but I only get 1 sig fig. So this becomes 1, and I just made this number bigger by a factor of 2, so I have to make this number smaller by a factor of 2. So this exponent is going to be 10 to the 4 quarts. So my answer is 1 times 10 to the 4 quarts. I only have 1 sig fig because I only had 1 sig fig up here. Okay? Let's do another one. All right? This one says, what is the speed in meters per second if a car is traveling 75 miles per hour? So I'm going to write down what I want. I want meters per second. This is a double unit conversion. I have 75 miles per hour. So you should see that I am going to need to convert hours to seconds and miles to meters. It doesn't matter which one I do first. It does not matter. I'm going to do the time first just because it's easier. Okay? So I know that in 1 hour there are 60 minutes. And I know that in 1 minute there are 60 seconds. Okay? So look what I just did. I just got my units of seconds. That's what I want over here. So I'm done with that part. Now I just have to keep building the problem. So I am going from English to metric, and I'm going with, and I'm doing length. So I am going to have to get to this conversion that gets me from the English system to the metric system, 2.54 centimeters in an inch. That means I need to get from miles to inches. That's a lot of converting. So I'm going to have to use 5,280 feet in a mile, and then I'm going to have to use 12 inches in a foot. All right, but that's okay. I can do this, all right? So here we go. There are 5,280 feet in 1 mile. Notice how I set it up like this so I can cancel out my miles. So now I'm in feet, okay? So I need to get to inches. So I'm going to say that in 1 foot there are 12 inches. Now I can cancel out my feet. Now I'm at inches. So now I can use this. I've been waiting to use this one. So now I'm going to say in 1 inch there is 2.54 centimeters. Okay? So now, hold on a second, I need a little bit more space here. So now I am going to, I need to get to meters, but I'm almost there. So I know that there are 100 centimeters in 1 meter. Wow, that was a big problem. Let me just double check that I have everything canceled. So I got my feet canceled, I got my inches canceled, I got my centimeters canceled, and I'm at meters per second. So now I'm finished building my problem. Now all I'm going to do is just do the math. So on my calculator, I'm going to take 75 times 5,280 times 12 times 2.54 divided by 60 divided by 60 divided by 100. Okay? The other way you could do this is you could say 75 times 5,280 times 12 times 2.54. And if you do that, actually, you get this big number. Divided by 60 times 60 times 100. But you will get the same answer, and then you have to divide, of course, meters per second. But you would get the same answer if you did what I told you on your calculator. So you type in 75 times 5,280 times 12 times 2.54 divided by 60 divided by 60 divided by 100. You will get the same answer. So up here I have 2 sig figs, right? 2 sig figs. So my answer has to have 2 sig figs. So I'm going to need to move over my decimal. This is going to be 3.3528 times 10 to the 1 meters per second, and I get 2 sig figs here. So this is going to round to 3.4 times 10 to the 1 meters per second. Okay? All right, hang in there. 2 more problems to go. Here we go. If a car is traveling 100 kilometers per hour, how far would it go in centimeters in 500 seconds? Okay, now, first thing I'm going to do is I'm going to write down what I want. I want centimeters. Now, this one is a little bit tricky. So I'm going to teach you, this is Mr. Laird's great problem. Do you see how this is Mr. Laird's trick, little kind of a tip. See how that's a double unit, kilometers per hour? And see how this is a single unit, it's just seconds? So Mr. Laird says if you want a single unit answer, then you start with your single unit piece of information. So it's going to be 0.500 seconds, okay? Now, do you see that I'm going to need to convert seconds to hours? Because I need to use this piece of information, and right now I can't use it because I'm in seconds. So I'm going to convert from seconds. See how I wrote 60 seconds on the bottom and 1 minute on the top? Now I need to get to hours. Okay. Now look what I just did. I converted my seconds to hours. Now I can use this double unit up here, but this is going to help me get to kilometers, all right, per hour. So look what's going to cancel here, guys. My hours are going to cancel, and now I'm at kilometers. But I have to get to centimeters, but that's okay. This is just metric to metric now. So I know that in 1 kilometer, there are 1,000 meters. I'm almost there. Now, in 1 meter, there are 100 centimeters. Okay, so I'm going to go back and make sure I have everything canceled now. My kilometers cancel with my kilometers, my meters cancel with my meters, and I have centimeters left. Isn't that cool? So now what do? Well, I'm going to take 500 times 100 times 1,000 times 100 divided by 60 divided by 60. The other thing that I could do is I can use my exponents here. This is 10 to the 2, this is 10 to the 3, and this is 10 to the 2. So I could also do it this way. I could say 0.500 times 10 to the 2 plus 3 plus 2. So that's going to be 10 to the 7. So this is 0.500 times 10 to the 7 divided by 60 times 60. Whoops, 60. And you could do this, you could do it the other way that I told you to, where you just take 500 times 100 times 1,000 times 100 divided by 60 divided by 60. You get the same answer. And your answer is, you get 1,3 88.88 centimeters. So I need to put that into scientific notation. So this is going to be 1, 2, 3. So 1.388 times 10 to the 3 centimeters. Now I got to check up here and see how many sig figs I get. So it looks like I get 3 sig figs, right? Because this has got 4 sig figs and that's 3 sig figs. So I'm going to get 3 sig figs in my answer. So I'm going to round this right here. So 1.39 times 10 to the 3 centimeters. That was a tough one. All right, one more problem. Hang in there. Here we go. If a bite of candy bar, has a mass of 800 milligrams, how many ounces does it contain? All right, so this is just a simple factor labeling. So I'm going to put ounces over here. This is what I want, ounces. I'm going to write what I'm given here, 800 milligrams, and I'm going to take note that I'm going to have 3 sig figs in my answer. So I'm going from metric milligrams to ounces English, and I'm weighing something, so I'm going to need to use the conversion of 454 grams in a pound. And in order to use that, I'm going to have to use that there are 1,000 milligrams in a gram, and then I'm going to have to use that there are 16 ounces in a pound. So I'm going to have to use all 3 of those. This is actually probably the easiest one we've done today. So let's set this up. I want to get rid of my units. So I'm going to put my 1,000 milligrams on the bottom and my 1 gram on the top. My milligrams cancel. I'm at grams. Now I can use this guy. 454 grams in 1 pound. I know to put that on the bottom because I need my grams to cancel. Now I'm at pounds. Now I can use this guy. 16 ounces in 1 pound. My pounds cancel. So on my calculator, I'm going to type in 800 times 16 divided by 1,000 divided by 454. And the answer you should get on your calculator is 0.02819 ounces. Move my decimal, 2.819 times 10 to the minus 2 ounces. I get 3 sig figs. I'm going to round right there. So 2.82 times 10 to the minus 2 ounces. Okay? So that's a lot of factor labeling in one little screencast. I would definitely suggest that you listen to it again and work the problems with me. See you in class.